All right, today we are going to do 14.3. We're going to come up with a bunch of formulas. These are formulas that we can use to manipulate and find, evaluate sine and cosine functions for more angles than just 30, 60, 90s, or when you end up on your quadrantals like 1, 0 or 0, 1. If you look at your formula sheet on page 407, these are the four that we're going to come up with right now. Okay, so we're going to come up with these four formulas. In order to do these proofs, so I'm going to prove them for you. In order to do these, there's some prerequisite stuff that we have to know. So we're going to start with that. So if you're in your packet, we're on page 408, 408. Okay. And first, we're going to talk briefly about even functions and odd functions. The definition of an even function is any function where if you take an f of x and then you take f of the opposite of x, you always get the same thing. Okay, so classic example would be something like f of x squared. F of x equals x squared. Okay, imagine if your input is 3, you get 9. Imagine if you change that input to be the opposite of that input, f of negative 3, you also get 9. Okay, anytime you plug in an input and then the opposite of that input, your outputs are the same. That's the definition of an even function. Okay, now for our purposes, the classic example of an even function is the cosine of an angle. Okay, if I take the cosine of, let's say, 30 degrees and the cosine of negative 30 degrees, notice I always get the same thing. Cosine of 30 degrees would be read 3 over 2. Cosine of negative 30 means I'm going in the opposite direction, and your cosine is exactly the same value. Okay, this always works for the function cosine. Cosine of x is always equal to the cosine of negative x. Okay, because they mirror each other. Imagine like cosine of 150, cosine of negative 150. Okay, you're still going to get this same x value. Okay, so here is a classic example of an even function. Cosine is an even function. Okay, now an odd function is when you plug in an input and then you plug in the opposite. You don't get the same thing, but you get opposites of each other. Okay, so this could be something like f of x equals x, or even f of x equals x cubed. Think about f of 3 would be 27. But then if I change that input to the opposite of that input, I end up with something that's the opposite of this output. So negative 27. Okay, so that's an odd function. It means f of x and f of negative x aren't the same thing. They're opposites of each other. So sine of theta, let's say you've got sine of 30 degrees versus sine of negative 30 degrees. Okay, well, 30 degrees would get you up here. Your y value would be 1/2. But now if I go in the other direction, if my input is negative 30 degrees, my output isn't 1/2, it's the opposite of 1/2. Okay, and that will always happen. When you change the input to the opposite sign, your output also changes to the opposite sign. Okay, so sine of x, if you compare it to the sine of negative x, they're not equal, they're opposites of each other. Okay, so you could put the negative on the outside on either one. Tangent works the same way. If you take tangent of an angle and tangent of the opposite of that angle, these aren't equal, they're equal to opposites of each other. Okay, that's because sine and tangent are odd functions. Cosine is an even function. Okay, so that's going to come up in one of the proofs that we do. Now our cofunction properties, or our complements. Okay, this looks goofy, but really it's something you probably already know. Okay, let's say, I'm just going to write this down. If I have any angle in the unit circle, I'm just going to do an angle over here. Let's say this is theta, and I know that this is 90. And I know the three angles have to add up to be 180. This is already 90, so this one has to be 90 minus theta. These two have to add up to 90 because this is already 90. Okay, and let's say this length is your x value, this length is your y value to get to this point x comma y, and this is the radius of your circle. Okay, maybe it's a unit circle, maybe it's one, but it doesn't have to be. Okay, now if you take the cosine of theta is adjacent over hypotenuse. And if I take the sine of not theta, but the sine of the complement of theta, sine of 90 minus theta. Well, the sine of an angle is not adjacent over hypotenuse, it's opposite over hypotenuse. But the opposite is now this side, x over r. Okay, so cosine and sine are cofunctions because cosine of theta is always going to be equal to the sine of the complement of theta, or 90 minus theta. Okay, and you could see how this would also work for tangent and cotangent. Okay, what's the tangent of theta? Tangent would be opposite over adjacent, y over x. Now let's take the cotangent of the complement. What's the cotangent of 90 minus theta? Well, the cotangent is adjacent over opposite, so that's also going to be equal to y over x. Okay, so tangent of theta and cotangent of the complement are also equal to each other. Okay, so let's fill out this chart. Cosine of pi over 2 minus x, remember pi over 2 is just another way of saying 90 degrees. Cosine of the complement of x is equal to the sine of x. And the sine of the complement of x is equal to the cosine of x. The cotangent of 90 minus x is equal to the tangent of x. And the tangent of 90 minus x is equal to the cotangent of x, because tangent and cotangent are complements of each other. They're cofunctions. Okay? Cosecant of 90 minus x is equal to the secant of x. Secant of 90 minus x equals the cosecant of x. Oops. Cosecant of x. Okay, so those are your cofunction properties. All right. Now we're going to go through the first proof, and this one's the longest. The rest of them come really quickly after this one. Okay. There is a little bit of a typo here. We're not going to prove cosine of a plus b. We're first going to prove cosine of a minus b. Okay. So I'm going to highlight that. There's a typo in your packet. This is actually the cosine of a minus b. Okay. So we're going to draw this out, an x and y coordinate system. I'm going to draw this over here, and this is going to be angle A. So from here to here, well, that's angle A. So this point right here is going to be cosine of A, comma, sine of A. Remember, your x coordinate is the cosine of your angle. The y coordinate is the sine of your angle. And you could see that if you were to draw your right triangle right here. Okay, assuming that this is a unit circle. So the x is just the cosine of A. The y is just the sine of A. Okay, now I'm going to draw an angle B. And angle B is going to get us to about right here. Okay, so this from here to here is angle B. So this point is going to be the cosine of angle B, comma, the sine of angle B. And this right here is going to, we're going to call the length of this side D, little d for distance between those 2 points. Now notice, if this is angle A and this is angle B, the angle between these two is going to be your angle A minus B. Okay, so that's our angle A minus B. So you can kind of see where this is going to go. Okay. Now what I'm going to do is I'm going to take this angle A minus B and I'm going to draw it in standard position. Okay, this is A minus B because this angle's A, this angle's B. But I'm going to take this triangle and I'm going to rotate it so that this side now lies along the positive x-axis. Okay, so this triangle is now going to look like this. I'm going to kind of erase this stuff. Just remember that those were, this bigger angle was angle A and this is angle B. It's just going to get too messy. So I'm going to redraw this over here. Okay, I'm redrawing the angle A minus B. So this angle is still angle A minus B. Okay, this point right here is going to be 1 comma 0. Remember, this is a unit circle. I'm going to assume if we drew a circle, this would be on the circle. All these points would be on our circle. Okay. This point right here, the x-coordinate is the cosine of the angle, cosine of A minus B. And the y-coordinate is the sine of A minus B. Okay. In this little side here, these are congruent triangles. The angle's the same. This is 1. This is 1. It's a unit circle. And so this has to also be a little d. Okay. So now what we're going to do is we're going to set this d squared equal to this d squared. Okay. So d squared, that distance squared. Okay. Well, we know that d is equal to the square root of x1 minus x2 squared plus this minus this squared, just using the distance formula. But if I square both sides, then little d squared is going to be equal to cosine of A minus cosine of B squared plus sine of A minus sine of B squared. Okay, it's just x2 minus x1 squared plus y2 minus y1 squared, and then square root of the whole thing is your distance, but squaring both sides will get rid of the square root. Okay, now I'm going to simplify this. Okay, so d squared is equal to, so think about foiling this. I'm not going to write it all out, but the firsts would be cosine squared A. The outers and the inners, we're going to have 2 of them, so minus 2 cosine A cosine B. Then we have plus this thing squared, plus cosine squared B. Okay. Then I'm going to get plus, I'll write it here, plus this thing squared is going to be sine squared A. And then outers and inners, we're going to have 2 of them, minus 2 sine A sine B plus sine squared B. Okay, now simplifying, d squared equals, now notice this cosine squared A plus sine squared A is equal to 1. Cosine squared B plus sine squared B is equal to 1. So we've got 1 plus 1, and we've got 2. And then I've got minus 2 cosine A cosine B. Just bringing this down and bring this down. Minus 2 sine A sine B. Okay, so that's going to be d squared when we use these 2 points right here. We're going to do the same thing to find what is d squared if we use these 2 points. Okay, so now what we get is d squared is equal to, so this minus this squared. So we get cosine of A minus B minus 1 quantity squared plus sine of A minus B minus 0 quantity squared. Okay, now we're going to FOIL. So d squared equals, this is going to be cosine squared of A minus B, and then minus outers and inners, so 2 cosine of A minus B, then plus, this minus 0 goes away, so we just get sine squared of A minus B. Okay, and now we've got a cosine squared of A minus B plus sine squared of A minus B is equal to 1. And I get d squared equals, what do I have? That's going to be 1 minus 2 cosine of A minus B. And that should be a 2. Why should that be a 2? Oh, I forgot this. So we're missing a 1 here. And the one that we're missing comes from, this should be a 2 here, and here's why. So when we FOIL this, we get this thing squared, then minus outers and inners. It's going to get minus 2 cosine of a minus b, and then plus this thing squared. So plus 1, and then we get plus sine squared of a minus b. Okay, so this plus this gives you 1, plus another 1 gives you 2, and I've got 2 minus 2 cosine of a minus b. Okay, now this d squared I'm going to set equal to this d squared. And bear with me, we're almost there. So I've got 2 minus 2 cosine a cosine b minus 2 sine a sine b equals 2, this right here, minus 2 cosine of a minus b. Okay, subtract 2 from both sides, those go away. And then everything that's left, I'm going to divide by negative 2. So I get cosine of a minus b is equal to positive cosine a cosine b plus sine a sine b. And there is our formula. I promise that's the longest one. The rest of them will go a lot faster. Okay? So if you look at your formula sheet, the very first one, cosine of a minus b, well, this is what we just derived. Okay? Cosine of a minus b equals cosine a cosine b plus sine a sine b. Okay? Moving forward, we're actually going to use this to prove the next one, and so on and so forth. Okay, so let's go to the next page, 409. Okay, now we're going to prove, and remember we changed this one. Your sheet says cosine of a plus b, but we actually first proved cosine of a minus b. So this one, we're going to now prove cosine of a plus b. And I'll highlight that also, just so you know there was a typo. So now we're looking at this one. Okay. Well, what we want to use is we want to use this formula that we just came up with. Okay. So I can rewrite a minus b as a plus b as a minus a negative b. Okay. So here's how I apply this formula. Cosine of something minus something is equal to cosine of your first angle times cosine of your second angle. So that's going to be cosine of A, cosine of the second angle, negative B. Okay, and then plus sine of your first angle, so sine of A, times sine of your second angle, sine of negative B. Okay, now we go back to our even and odd properties. Remember that cosine of opposite b, since cosine is an even function, cosine of opposite b simply equals cosine of positive b. Bring down the cosine a, plus, and then we've got sine of a. Now, sine of negative b, sine's an odd function. So sine of negative b does not equal sine of positive b. It equals the opposite. So this gets multiplied by negative sine of positive b. Notice when we change our input from negative to positive, it makes the whole thing negative. So this now times a negative gives us minus sine A sine B, and we've got cosine A cosine B, and this is your formula for cosine of A plus B. Okay, so looking at your formula sheet, this is now the second one, cosine of A plus B, okay, which is equal to cosine A, cosine B, cosine A, cosine B, minus sine A, sine B. Okay, now we're going to go the last two. Sine of A minus B we're going to prove, and sine of A plus B. Okay, these are even faster. Okay, because what we're going to use for this, we're going to use the cofunction properties. Okay, remember that cosine of x equals sine of 90 minus x, sine of x equals cosine of 90 minus x. So sine of A minus B is equal to cosine of 90 minus this angle A minus B. Okay, so now we're going to break this apart and say this is equal to cosine of, and I'm going to do 90 minus A plus B. 90 minus A plus B. Just distributing that negative. So 90 minus A plus B. And I'm going to group these together. This is going to be cosine of 90 minus A plus B. Okay, so now I'm going to use the formula for cosine of an angle plus another angle. So that's this one right here. We're now going to use this one. Okay, so cosine of A plus B is cosine of the first angle, which is 90 minus A, times cosine of the second angle. And then we've got minus sine of the first angle, 90 minus A. And then sine of the second angle, sine of B. Okay. And now we know cosine of 90 minus A, well, that's equal to the sine of A. Bring down the cosine B, and then minus sine of 90 minus A is equal to cosine of A times sine of B. Okay, so this is the sine, your formula for sine of A minus B. Okay, you might be wondering at this point, what the heck are we going to use all these for? And I'm going to show you that in a minute, but let's just get through the rest of this page, and I'll show you what the purpose of all these and why they're so useful. So let's just double check. Sine of A minus B equals sine of A cosine B minus cosine A sine B. Okay, we've got one more, sine of A plus B. Well, that's equal to the cosine of 90 minus this angle, A plus B. So let's rewrite that as cosine of 90 minus A minus B. Okay, so that's cosine of 90 minus A minus B. So now we're going to use the formula for cosine of A minus B. Okay, the very first one we did. This one, cosine of A minus B. So that's going to be cosine of the first angle times cosine of the second angle plus sine of the first angle, sine of the second angle. Cosine of the first angle, 90 minus A, cosine of the second angle. Okay, and then we get a plus sine of the first angle, 90 minus A, times the sine of the second angle. Now, cosine of 90 minus A is equal to the sine of A, cosine B, plus sine of 90 minus A is equal to the cosine of A. Bring down the sine of B. And this is the sine of A plus B equals, and here's our next one. That's the last of the four. Sine of A plus B equals sine A cosine B plus cosine A sine B. Okay. And then the next one, tangent of A plus B. You don't have to memorize all these, but tangent of A minus B and tangent of A plus B, these are the formulas. Okay. But tangent of A plus B, the way that we derive this is tangent of an angle is equal to the sine of an angle over the cosine of the angle. Okay, so now I'm going to rewrite the sine of A plus B. Well, that's sine of A cosine B plus cosine A sine B. I just used the formula right off the formula sheet for sine of A plus B. And this one's going to be cosine of A plus B is cosine of A cosine of B minus sine A sine B. I know these seem like they might be hard to memorize, but they're actually not hard to memorize. Once you start using them, there are patterns that you'll start to recognize, okay? So if you recognize in this, for tangent of A plus B, notice there's only tangents over here. So we have to figure out how to get rid of all these sines and cosines and get tangents. Okay, so what I'm going to do is going to multiply the top and bottom by a clever form of 1. Remember, tangents have cosines in the bottom. So if I can divide everything by cosines, so I'm going to take the top and multiply 1 over cosine A, cosine B, over, and the bottom I'm going to do the same thing, 1 over cosine A, cosine B. So this right here is just one big clever form of 1. Distribute this to the first one. The cosine B's cancel, and you get sine A over cosine A, which is tangent of A, plus this times this. The cosine of A's cancel, and you get sine B over cosine B, which is tangent of B. On the bottom, you've got cosine A, cosine B divided by cosine A, cosine B when you distribute this to the first term, so that's just a 1. And minus sine A, sine B, if you have that on top, over cosine A, cosine B, well, that's tan A times tangent of B. Okay, so there's your formula for tangent of A plus B, which is this one right here. Okay, and then the next one, I'm not going to go through this proof, but it's the same exact thing that you would do, and this one comes out to be tangent of A minus tangent of B over 1 plus tan A tan B. Okay, now drum roll. Let's see, why the heck do these, what we're going to use all these things for? Okay, yeah, and you can verify these on the Inspire if you want to. Feel free to go do that. So what are we going to use these for? Well, if you have something like sine of 105, if you drew that on the unit circle, you'd be like, okay, sine of 105, that gets me to 90. It gets me 15 past here. My reference angle is going to be 75. I can't do anything with that, can I? Okay, but now you can with these formulas. Can we get two angles that add up to 105? Usually what I'm trying hardest to do is use angles like 45, 45, 90s, and 30, 60, 90s. So I take the angles 30 and 60 and 45, and can I add two of those together to get 105? And there's not only one right answer to do that part of it. But as long as you did it correctly, no matter what angles you choose to add up to 105, you're going to get the same correct answer. So sine of, and I think I'm going to use 60 and 45. Again, we're looking for some kind of adding up, and we only want two angles. Don't find three angles. Don't do 30 plus 30 plus 45. Use 60 and 45 here. We also could have done 30. Let's see if we did 30 and 75. That doesn't work. This might be the only one that works. Okay. So sine of A plus B, we'll use your formula sheet. Sine of A plus B. So we're going to use this one at the bottom. That's sine of A cosine B plus cosine A sine B. So that's sine of your first angle A, 60, cosine of your second angle, and then plus cosine of your first angle, sine of your second angle. Cosine of 60, sine of 45. Okay, and then here we can do sine of 60. If you need to draw it out, okay? But sine of 60 is rad 3 over 2. Cosine of 45 is rad 2 over 2. And plus cosine of 60 is 1/2. Sine of 45 is rad 2 over 2. Okay. So hopefully now that we've done chapter 13, these are pretty easy to come up with. But if you need to, draw them out. Okay, let's simplify. That's going to be rad 6 over 4. Then plus 1 times rad 2 over 4. Okay, let's do this one. If you need to change it into degrees, you can change it into degrees, but let's see if we can do it without changing it into degrees. If you do, let's see, 3 pi over 6 and 2 pi over 6, let's write 3 pi over 12 plus 2 pi over 12. Remember, if we want to find two angles, 45s, 60s, and 30s, so 45, 60s, and 30s, but in radians. Okay, so in radians, 45 degrees is pi over 4. So here's my pi over 4. And then here's a pi over 6. So this is, oops, I forgot the cosine. Cosine of this. So So that's cosine of pi over 4 plus pi over 6. If you need to go do the conversion, multiply by 180 over pi, change it to degrees, and then find two that are degrees. But hopefully you're getting better at radians, and you could do this with radians. Cosine of a plus b is cosine of your first angle, cosine of your second angle. And with this one, then it's minus sine of pi over 4, sine of pi over 6. Again, you don't have to have that memorized, but you're using cosine of a plus b. That's this one right here, cosine of a plus b, cosine of your first angle times cosine of your second angle. And if this was a plus, this is now a minus over here. Notice some of them, for the cosines, the minus changes to a plus. The sines, a minus b and a plus b, they don't change. So the minus stays a minus. Okay? But you kind of mix and match. You do sine a, cosine b, cosine a, sine b. For this one, it's all cosine, cosine, sine, sine. Cosine, cosine, sine, sine. Okay? And finishing up, cosine of pi over 4 is rad 2 over 2. Cosine of pi over 6, that's a 30-degree angle, so that's going to be a rad 3 over 2. And then minus sine of pi over 4 is rad 2 over 2. Sine of pi over 6 is 1/2. So I get rad 6 over 4 minus rad 2 over 4. Okay. 345. Okay. So you want to find two angles. You could also do minus. You could find an angle and subtract another angle. You could rewrite 345 not as the sum of two angles. Like here we did the sum of two angles, sum of two angles. You could rewrite as the difference of two angles. I think this one's maybe a little easier to do sum because we could do tangent of 300. 300, remember where that ends up? That gives you a 60-degree reference angle. Okay, and then plus 45. So that would be, and this is tangent of a plus b. So that's this one over here. Tangent of a plus b is tan a plus tan b over 1 minus tan a tan b. So that's going to be tangent of 300 degrees plus tangent of 45 degrees. On the bottom, we get 1 minus tangent A, tangent B. 1 minus tangent 300 times tangent of 45. So tangent of 300, sometimes you might want to scribble this out. 300 gets you down here. The 60-degree reference angle, 300 is 60 short of 360. So here's your 1/2. And here's your negative rad 3 over 2. Okay, so this side would be the 1/2. This would be the negative rad 3 over 2. The tangent of that angle is going to be this divided by this. So that's a negative rad 3. And then tangent of 45. Remember, tangent of 45, your two legs are the same, rad 2 over 2 and rad 2 over 2. So that's going to be 1. So plus 1 over 1 minus negative rad 3 times 1. Okay, so I get negative rad 3 plus 1 over 1 plus rad 3. Now we have to multiply by our clever form of 1. That's going to be the conjugate of the denominator. So 1 minus rad 3 over 1 minus rad 3. Okay, so we have to FOIL on the top, FOIL on the bottom. It's going to be negative rad 3 plus rad 3 times rad 3 is 3. And then plus 1. Then minus rad 3. Bottom, I've got a 1. Outers and inners cancel, and then I get a minus 3. Okay, so on the top, I get 4 minus 2 rad 3 over negative 2, which simplifies 2. That's a negative 2 plus rad 3. Okay, and you can type this in on your calculator to check and make sure you did that right. Okay, I think I already just did that. Tangent of 345. Remember, the calculator always wants to give you an exact answer. So rad 3 minus 2. Okay. Now, these next types of problems, they look hard. They're not hard. You're just plugging into the formula. Okay. Much easier than what we just did. But we want to do sine of something plus cosine of something. So sine of a plus b plus cosine of a plus b. So we're going to use this formula, sine of a plus b, which is sine of the first angle cosine of the second angle, and then plus cosine of the first angle, sine of the second angle. Okay, that's all the first one. You have to write a little bit small here. Then plus, now this thing is going to be another big expanded out definition using cosine of A plus B. So cosine of the first angle, cosine of the second angle, minus sine of the first angle, sine of the second angle. So cosine x cosine 60 minus sine x sine 60. Okay, and we're hoping this simplifies to just come out to be that. It's like they already gave us the answer. We're just hoping. We know if we got it right. Okay, sine of x times cosine of 30. Well, cosine of 30 is rad 3 over 2. And plus cosine of x times sine of 30. Sine of 30 is 1/2. And plus cosine x times cosine of 60. Cosine of 60 is 1/2. And then minus sine of x sine of 60. So that's rad 3 over 2. Okay, so I've got a sine x rad 3 over 2 and a minus sine x rad 3 over 2. Those go away. Okay, then I've got 1/2 cosine x plus another half of cosine x, 1/2 cosine x. If I have 2/2 of cosine x, those add up to be cosine x. So this is like the little proofs that we did in the last section. Okay, prove that the given equations are identities. Prove that these are the same thing. Okay. Now this one, we'll go work from the left side to the right side again. So I've got a rad 2. Now I'm going to use the formula for cosine of A minus B, which is cosine A cosine of B plus sine of A sine x sine of pi over 4. Again, you don't have to have this memorized. Use your formula sheet if you don't remember cosine of A minus B. Now we simplify. So that's a pi over 4, right? Okay. So rad 2, and I got cosine of x times cosine of pi over 4 is rad 2 over 2. Then minus sine of x, sine of pi over 4. Well, sine of pi over 4 is rad 2 over 2. Okay, let's distribute this rad 2 to both terms. So that's going to be rad 2 times rad 2, which is 2 over 2. So 2 over 2 cosine x. I get, sorry, that should be a plus. I don't know why I brought that down wrong. So that's a plus. Plus rad 2 times rad 2 is 2. 2 over 2 sine x. 2 over 2 is just 1. So that's just cosine of x plus sine of x. Okay. And I think we've got what, one more page? Okay. If you want, feel free. Stop the video, work through these problems, but I will work through the rest of these. I will work through this page. Just take a few more minutes. Okay. Sine A cosine B plus cosine A sine B. Let's say this 75 is your A and 15 is your B. We're simplifying. So this right here is the formula. It's one of your sine formulas, sine cosine plus cosine sine. This is actually the formula for sine of A plus B, which is sine A cosine B plus cosine A sine B. So hopefully you recognize this formula is right there on your formula sheet, which means when A is 75 and B is 15, this is just sine of 75 plus 15. You don't have to do all these. These would take forever to break all those down and do that 4 times. What you're doing is working backwards. You're recognizing this is a pattern. It's a pattern for sine of A plus B, where A is 75, B is 15, A 75, B 15. That's just the sine of 90 degrees, which is 1. Boom, you're done. Okay. See if you can find this one. Cosine, cosine, sine, sine. Well, cosine A, cosine B. So if A is 5 pi over 12, this would be another A, this would be another B, if B would be pi over 12. That's the formula for cosine of, I believe it's A plus B. Let's double check that on your formula. Again, you don't have to memorize them. So when you've got cosine, 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 sine, sine, and a plus in the middle. Oh, we want the minus in the middle. So that's going to be cosine of A plus B. So we have that right. Okay. So that's simply cosine of 5 pi over 12 plus pi over 12. Okay, that's cosine of 6 pi over 12, which is pi over 2. Cosine of pi over 2 gets you to here, to the point 0, 1. Cosine's your x value, so that's equal to 0. Okay. Now this one, sine, cosine, cosine, sine, that's one of your sine formulas. That's sine of, if this is your A, 3x is your A, 2x is your B. This is going to be the formula for sine of A minus B. Double check that. Sine of A minus B. Well, that's sine A cosine B, sine A cosine B minus cosine A sine B. Okay. So that's just the sine of 3x minus 2x. Okay, so that's the sine of 3x minus 2x is 1x. You just get sine of x. That's all you can do here. Okay, sine, cosine, cosine, sine, that's one of your sines. That's going to be sine of A minus B. It's actually the same formula as this one, isn't it? Sine, cosine, cosine, sine with the minus in the middle. Sine, cosine, cosine, sine with the minus in the middle. Okay, where this thing's your A, 4 pi over 3 is your A, pi over 3 is your B. So that's going to be sine of 4 pi over 3 minus pi over 3, which is sine of 3 pi over 3, or just pi. Sine of pi is 0. Okay, and let's just go down and do this one. Suppose that sine of alpha is 3/5, sine of beta is 24 over 25, where alpha is between 0 and pi over 2, beta is between pi over 2 and pi. Oh, that's a lot of information, okay? But we can do that. First, I'm going to draw alpha, and I'm going to draw beta. Okay, I know that alpha is between 0 and pi over 2, so I'm going to draw that over here. I know that beta is between pi over 2 and pi, so I'm going to draw that over here. So here's beta. Okay, sine of alpha is 3 over 5. Okay, I'm not going to draw a unit circle. I'm going to do opposite over hypotenuse, and that's a 3, 4, 5. Sine of beta, sine of this angle, is 24 over 25. So opposite over hypotenuse, 24 out of 25. Well, that's a 7, 24, 25. Notice that since it's quadrant 2, your x value is negative. Okay, so now sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Okay, so sine of alpha, look at your picture, is 3 over 5. Cosine beta, look at your picture, here's beta. Cosine is negative, is adjacent over hypotenuse, so negative 7 over 25. Plus cosine of alpha, look at alpha where you drew alpha. Cosine is adjacent over hypotenuse, so 4 over 5. Sine of beta, go back to beta. We want the sine of this angle, which is going to be opposite over hypotenuse, or 24 over 25. Okay, so this is going to be negative 21 over 125 plus 4 times 24. I think that's 96 over 125. 96 minus 21 is 75 over 125, which is 3 over 5. Okay. And the last one. Okay. Fortunately, this is the same thing. We still have the same alpha and beta, same picture we drew. So cosine alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. Cosine alpha is 4 over 5. Cosine beta is negative 7 over 25. Plus sine of alpha is 3 over 5. Sine of beta is 24 over 25. So that's going to be negative 28 over 125 plus 72 over 125. 72 minus 28, 62, 52, 44. I think I did that right. All right. Well, that's all, folks. That's all we got for today. Hope you enjoyed the video. Thank you for watching.